So this is the AQA Level 2 Certificate in Further Maths Specimen Paper 2. So you can use a calculator. And let's start having a look at question 1. So we're given a sketch of 2 lines for me to work out the area OPQ. So if we think about the key points on this triangle, so we know this is a line y equals 6. Okay, which means that point there is 6. What we could do with finding is the intersection point Q. So to find Q, we know that y is 2x and y is 6. So therefore, 2x must equal 6, which means that this is the point 3, 6. Okay. So if we're trying to find the area, I've now got the base is 3, the height is 6, and I can work out the area as half base times height. So my area is 9. Okay, you can also use your graphical calculator if you are lazy, like me, and don't want to find the intersection points by hand. Okay, so draw the lines y equal 2x, draw the line y equals 6. Okay, and then we can just find the intersection point super quick by saying that's 3, 6. And then obviously that tells you the height and the base straight away. Okay, so definitely make use of your calculator. Question 2. We've got a circle, centre 0, 0 has got circumference 20 pi. We want to work out the equation of the circle. So we should know the equation of a circle is x squared plus y squared equals the radius squared. So I need to find out what the radius is. So if my circumference is pi times the diameter, apologies for my pen being rubbish today. Okay, that tells me my diameter is 20. Okay, so if my diameter is 20, my radius must be 10. So it would be x squared plus y squared equals 10 squared, which is 100. For question 3, just some work with midpoints. So remember, to find the midpoint between 2 points, we average the x coordinates and we average the y coordinates. So if we look at our x coordinates, to get my midpoint P, I'm going to average my x coordinates. So 7, add minus 2, and divide that by 2. That gives me P is 2.5. And average your y coordinates. So if I average my y coordinates, I get my midpoint coordinate, which is minus 1. So I'm averaging 3 and r. So if we solve that, so minus 2 is 3 plus r. That gives me r is minus 5. Okay, or if you're more of a visual person, you can think about it from the diagram. So I'm going from 3 down to minus 1. Oh. So my step down and my step along are going to be the same. So if I'm going from 3 to minus 1, that gives me a drop of 4. Sorry, my pen is really not happy today. Okay, so that means I'm going to have another drop of 4, so minus 1, to get down to minus 5. do the same thing as step along. Okay, so from -2, I step along to get P, and I step along again to get 7. So this whole step here goes from -2 to 7 is 9. So therefore, it's going to be 4.5 along as one step, so 4.5 along. And 4.5 along from -2 would give me 2.5. Okay, so some people are more visual, prefer doing it on the diagram. Question 4, just solving this equation here, this inequality over here. So -3x is less than -18, so I need to divide by -3. Okay, and remember, if you're dividing by a negative number, you need to change the inequality sign. So that gives us x. I'm going to change the inequality sign because I'm dividing by a negative number bigger than 6. Okay, so just remember, this question is just a test about whether you remember to change the sign when you divide or multiply by a negative number. For this one here, so x squared is bigger than 16. Okay, anything that is a quadratic inequality, you do need to draw the graph. Okay, so if you get everything on one side, if we draw the graph of x squared minus 16, okay, and then you can use that to find the roots, which are obviously 4 minus 4. Okay, so just sketch the graph. Okay, and then we're looking for the part of the graph, because we want it where it's bigger than or equal to 0, we're looking at everything above the x-axis. So we're looking at these parts of the graph here. So this part and this part. Okay, that's the part of the graph that we're interested in. So if we picked any values, if I picked a number off this graph and read down, it would be bigger than 4. And on this side, it would be smaller than -4. So your answer is it's bigger than or equal to 4 and smaller than or equal to -4. Okay, so remember to always draw the graph of any quadratic inequality. Next question. Here is a sketch of y equals fx. So we've got a quadratic function. Tells us it intersects the x-axis A is -1. And B, and it tells us the maximum point is 1/2 and 6. So we want to work out the coordinates of B. So remember, a quadratic graph is always symmetrical. So it gives you the midpoint, maximum point, sorry. Okay, that's going to be the midpoint of the roots. So if we look at this gap here between -1 and 1/2. Okay, then we've got a gap of 1.5. So you can have another gap of 1.5 here. Okay, so B will be 2, 0. So the equation fx equals k has one solution. Write down the value of k. So if we think about this graph here, so the line y equals k is going to be a horizontal line. So if I draw a horizontal line through this graph, most of the time it's going to have two solutions. So it crosses here and here. The only way I could put this straight line, this horizontal line, so that it touches once, is if I put it right at that maximum point. Okay, so it's the only place on the graph where I'm going to get one solution. If I go above it, I'm going to have no solutions because it won't cross at all. If I go below it, I'm always going to have two solutions. So therefore, you have to do it at the maximum point. So your equation of your line is going to be y equals 6. Well, actually, it just wants the value of k, not the equation of the line. So k is 6. Okay. Question 6. We've got 4 matrices, and we know that A, B equals C, and we're trying to work out the values of S and T. So because you can multiply matrices together on your calculator, they do like to put in unknowns like S and T to stop you, to show that you have to use your actual knowledge of matrix multiplication rather than just doing it on your calculator. Okay, so let's multiply these together. So 4 times 5 gives me 20. Minus 1 times minus 5 gives me 5. So you're doing 20, add 5. And then for my second one, I did minus 7 times, sorry, my bad. I can't read my own writing. That is an S. Make it really curly S. Let's try that again. So 4S. And then minus 1 times minus 5 is plus 5. So that part was right. Is my first one. And I've got minus 7 times S. And 2 times minus 5 is minus 10. So that is going to give you minus 1t. So if I look at my top row, I can work out the value of S because I'm solving 4S plus 5 equals minus 1. So 4S is minus 6. So S is minus 6 over 4 or minus 3 over 2. Okay, I can then use that to find T if I look at my second line. So minus 7 times minus 3 over 2 minus 10. Give me my value of T. So that gives me a value of T is a half. Okay, so that's quite a common type of question on the calculator paper to avoid you just using your calculator. If we look at part B, so A multiplied by D gives me the identity matrix. So 4 minus 1 minus 7, 2. So here's my matrix A. And D is 2, 1, 7, U. Okay, so I know when I multiply this together, I'm going to get the identity matrix, which remember is 1. It's got leading down the leading diagonal, you've got 1s, so 1, 0, 0, 1. So if we multiply these together, so 4 times 2 gives me 8. Minus 1 times 7 gives me minus 7. If we go to the next one, 4 times 1 gives me 4. Minus 1 times U gives me minus U. Down here, I've got minus 7 times 2 gives me minus 14. 2 times 7 gives me plus 14. And then this one here, minus 7 times 1 is minus 7 and 2U. Okay, so if you're trying to find the value of U, it doesn't really matter which value you pick, but the easiest one to pick, I would say, if you match up this one and this one. So 4 take away U gives you 0, must give you a value of U is 4. And that should work wherever you put it. So minus 7 plus 2 times 4 is 1. Just check in. 8 minus 7 is 1 from 14. Okay, so that all the terms match up. Okay, this is quite a simple equation of a straight line. So it's parallel to 2y equals x. I'm just going to rearrange that So you've got y equals a half x. So in other words, the gradient is a half. So if it's parallel, it's going to have the same gradient. So our line is also going to have a gradient of a half. And then we're going to use y minus y1 equals mx minus x1. So it goes through for 0. So y minus 0 is a half x minus 4. So y is a half x minus 2. Okay, so relatively simple and straightforward question on coordinate geometry. Question 8. It's got some algebraic fractions. So we're dividing these fractions. So we're going to multiply by the reciprocal. So multiply and switch the other fraction upside down. Okay, and then have a look, see if there's anything that cancels. So I've got a B and a B that cancel out. Here, I've also got a D and a D that cancel out. So I'm left with A squared on this side, and then C squared on the bottom. Pen is not happy today. There we go. Okay, so it'll just be A squared over C squared. When you're adding fractions together, remember you want a common denominator. So we're looking for a common denominator of 2x squared and 3x. So if we look at the numbers to start with, so 2 and 3 both go into 6. And if we look at the letters, x and x squared both go into x squared. So don't be tempted just to multiply your denominators together to get your common denominator, because then you'll end up with lots of cancelling. Try and find the lowest common denominator. So for this, I've got to multiply my denominator by 3 to get 6x squared. So I'm also going to do the same to the top. For my next fraction, I need to multiply the bottom by 2x. So I'm also going to do the same to the top. So it gives me 8x over 6x squared. Then when you add them together, you can just add the numerators. Okay, to get 21 plus 8x over 6x squared. Question 9. So with questions on circle theorems, they're quite often algebraic in further maths. So just think about what links together, what circle theorems you've got in there, what you can link together. So straight away, I can see I've got the angle at the centre and I've got the angle at the circumference. So I know that the x plus 62 is going to be double the angle at the circumference, so 2x minus 50. Okay, still need to put your reasons. So the angle at the centre is twice the angle at the circumference. Okay, so I can use that fact to solve that equation and find out what x is. Okay, so it's just a simple linear equation to solve. So I know x is 54. Okay, I can then use that to find y. So if I add 62, I'll find the angle at the circumference, centre, sorry. So this is 116. Okay, so then you've got an isosceles triangle, so OB and OC are equal because they're both the radius. So you've got an isosceles triangle. I don't know what's happened here. Okay, you've got an isosceles triangle, and you can just work it out using angles in a triangle. So 180 take away 116 divided by 2 gives me 32. So the reason for that is angles in an isosceles triangle. Okay, it's really easy to make silly little mistakes with solving linear equations, for example. So I'm just going to put that into equation solver. So remember, any polynomial goes into the polynomial solver, anything else. So linear equation, you can just solve in here. So I'm just going to make sure I solve my equation right by entering that first equation in there, pressing solve, and I've got x is 54. So now I've done that part right. Question 10. Find the second derivative when x is 0.5. So I'm going to have to sort out this y first. Okay, so when you've got two terms over one term, just split them up. So you've got 6x to the power of 9 divided by 2x to the power of 4. And then you've got the second term. So you've got 8 to the power of 8 over 2x to the power of 4. Okay, so this allows you to simplify each term separately. So we've got 6 over 2 gives me 3, and then x to the 9 divided by x to the 4. Remember, you subtract the powers, so it gives me x to the 5. And then for the next ones, the numbers stay where they are, I can't cancel them. I've got 1 over 2, which is a half. And then x to the 8 divided by x to the 4. Again, subtract the powers, gives me x to the 4. So now it should be a lot easier to differentiate. Okay, so bring the power to the front, take 1 off the power. Bring the power to the front, take 1 off the power. I want the second derivative for this question, so I have to differentiate again. So take the power to the front and take 1 off the power. Take the power to the front and take 1 off the power. So I'm interested when x equals a half. So I'm going to substitute x equals a half in. Okay, which gives me a value of 9. Okay, remember your calculator can do numerical differentiation for you. So it can't find the expression for you, it won't give you the actual derivative, but it can differentiate for you and substitute a number in. So if you go to options, calculus, and then you can see there F3 is the second derivative. So we're just going to type in the original equation. We want a second derivative of, you don't have to put the simplified version in, you can put it unsimplified. So 6x to the power of 9 plus x to the power of 8 divided by 2x to the power of 4. We want that when x equals, forgive me in the little box, .5. Okay, and it tells you it's 9. So remember, you do get full marks for the right answer in the exam. So if you put 9, they would give you the benefit of the doubt and give you full marks. Okay, so if you get stuck on a question like this, take advantage. However, if you type it in wrong, or for example, if you put the first derivative in your calculator, you lose all 5 marks. So always try and show you're working as much as possible. Use your calculator to check. But as a last resort in the exam, if you can't do it, whack it in your calculator. Question 11 is a sequences question. So it gives us the nth term for a sequence A and a sequence B. Then it tells us the kth term of sequence A equals the kth term of sequence B. So we want to find out what that value. So in other words, what is the value where these two expressions are equal? So we've got n over 14n plus 30. We want to know where that equals 2 over n. Okay, so I'm going to cross multiply. So n squared is equal to 2 14n plus 30. I'm going to expand the brackets. So I've got 28n plus 60. And that gives me a quadratic to solve. Okay, so because it is a calculator paper, I am just going to be lazy and solve that on my calculator. So A is 1, B is minus 28, C is minus 60. Okay, so it is one that factorises. So it is 30 in minus 2. Okay, but remember, n is a position, it's a term. Okay, so it's the nth term, so we can't have a negative value because you can't have the minus second term. Okay, so n is actually just 30, or k is 30. Okay, you can also graph both of those expressions, then you don't have to do any algebraic manipulation whatsoever. So if you draw the graph of x over 14x plus 30, and then draw the graph of 2 over x. Okay, then obviously the point at which they intersect is going to be the bit we're interested in. So I'm just going to change my view window a little bit. I don't want any negative numbers, not interested in negative numbers. Now I can see the graph goes on for a while, so I'm just going to push that up to 50. So now if I press G solve, intersect, I can see it intersects at 30. So I've definitely done it right. Okay, this question does say you must show your workings, so use that as a checking mechanism. If you didn't do that in the exam and you just put the answer, because it says you must show your working, they wouldn't give you full marks for this question. Question 12. So you've got this shape, compound shape, that has got the different dimensions on it. And the perimeter of the shape is 252. So we want to find an expression for y. So let's have a think about what the perimeter would be. Okay, so I'm going to think about my horizontal lines first. So I've got 30x here on this line here. I've got 30x here and here as well, because obviously they add up to 30x. Okay, so I've actually got 60x for my horizontal lines. And then I've got 15x and y. But I've actually got 2 lots of those, because if I put those together, those 2 would add up to the same as this side here. So I've got 15x add y as one side, but it's also going to be the same as the other side as well. Okay, so I then know my perimeter is going to be 252. Okay, so I'm just going to multiply the brackets. So I've got 90x add 2y is equal to 252. And then obviously if I rearrange it to find y, then I can halve it. So I've got 126 take away 45x is equal to y. So relatively straightforward. Show that. The area of the shape is A. So let's have a think about how I'd find the area. So I'm going to split it up. So I've got this big rectangle and this small rectangle. So the big rectangle A would be 20x multiplied by 15x plus y. Okay, and then I've just worked out what y is, so I can substitute that value of y in. So it's actually 20x multiplied by 15x plus, and remember y was 126 minus 45x. Okay, so putting that together, we have got 126 minus 30x, and I'm also going to multiply the brackets. So 126 times 20 gives me 2,520x, and then 20x times 30, it gives me 600x squared. If we then think about the area of B, so B is just 10x times 15x. That one's quite easy. That gives me 150x squared. So my total area, if I add those together, is going to be, oh, that should have just x on it, sorry. And that was what the show that was. I was giving them the show that. Okay, so part C, use differentiation to work out the maximum value of A as x varies. So as soon as you see the word maximum, you should be thinking about differentiating. So I want to differentiate A with respect to x. So that gives me 2,520 minus 900x. Okay, and then think about a graph. Remember, on a graph, doesn't matter what the graph looks like. Okay, but whatever this maximum point is, the tangent is always got a gradient of 0. So we make, to find the maximum or the minimum, we make the differential equal to 0. Okay, and then solve that to find the value of x. So 900x is 2,520. So if I divide by 900, the value of x that gives you the maximum is 2.8. Okay, it doesn't want the value of x at the maximum, it wants the actual maximum value of A. So we then need to substitute that back in to find the area at x equals 2.8. So if we sub that back into the area formula, so remember the area was here. So we're doing 2,520 multiplied by 2.8 minus 450 times 2.8 squared. So 3,528. Okay, and then centimetres squared. Okay, we can check that on the graph. And it does say use differentiation to work out, so you couldn't do this as a technique from the start. Okay, but definitely use it to check. So if we if we type in our area formula, remember this was a show that, so even if you hadn't showed that, you've still given it in the question. So let's draw the graph. Let's zoom in auto, you should see it. So try and see the maximum. Okay, so as soon as you can see the maximum, if you press G solve max, it will tell you what the maximum value is. So X is 2.8 and Y is 3,528. So no, I've got the question right. Question 13 is a functions question. So remember, G, F4 means you're subbing 4 into F, and then you're subbing that answer into G. So to start with, we want to work out what F of 4 is. Okay, so 3 times 4 squared plus 6. Okay, and then when you've got your answer to that, so that's 54, then we're subbing 54 into G. So it's like G of F of 4. So we've worked out that part there. So we're putting the 54 into G. So 54, take away 5 and square root it is the square root of 49. So it would be plus or minus 7, but it does tell you in the question, X has got to be bigger than or equal to 5. Okay, so we're not interested in the negative value, so we just want 7. Okay, so we're rejecting that answer. And now what's the expression for FGX? So remember, it was like having brackets around here. So you're subbing G of X into Fx. So wherever you see an X in Fx, we're going to replace it with the expression G. So we've got F of, so we're putting root X minus 5 into that expression for F. So every time we see an X, we're going to replace it with root X minus 5. So 3 root X minus 5 squared plus 6. Now, obviously, if you're square rooting and squaring, that actually cancels it out. So it's just 3 x minus 5 plus 6. And then we can multiply the brackets. Collect like terms. Minus 15 plus 6 minus 9. And then factorise at the end. Okay, so it's put it in this form that is factorised as given into the question. Question 14 wants us to use the sine rule to work out the size of the obtuse angle X. Keyword in this question is obtuse. So remember, your calculator will always give you acute angles. Okay, so what have we got? We've got that sine X divided by the side opposite, so 2y. This is like your A and your little a, B and your little b, equal to sine 18 divided by y. Okay, so if we're trying to work out what sine x is. So we're trying to find x as the end goal. Let's do a bit of cross multiplying. So y multiplied by sine x is equal to 2y multiplied by sine 18. Okay, so I can actually divide all of this through by y. So the y's disappear. So sine x is equal to 2 sine 18. So on your calculator, we do 2 times sine 18. Okay, we've got 0.618. Just going to make sure I'm in degrees. I am in degrees. Okay, so equals 0.618. So then if I do inverse sine of that answer, it's going to give me the acute angle. So x equals 38.2 degrees. Okay. Now, there's lots of different ways of thinking about this. Some people just learn that to find the obtuse angle, you take it away from 180. Okay, so we're going to do 180, take away that answer. So our angle is 141.8. Okay, different ways of thinking about it. If you use a cast diagram, the reason we do that gives you the acute angle. Remember to find the next angle in S, because we're talking about sine, you're always going to do 180, take away whatever this angle was because of the symmetry of the cast diagram. Okay, if you're not a cast diagram fan and you prefer thinking about the graph, okay, you can think about the graph. So remember, this is 180. Okay, again, the same thing, symmetry of the graph. So because of the symmetry of the graph, if this is 38.2, we'd take it away from 180 to get this value here. Okay, but in a nutshell, we always take it away from 180 to find the obtuse angle in the sine rule. Question 15. So we are trying to find the values of A and B. Okay, your calculator does do questions like this for you. So if you use in the stats mode, you can go to regression. However, it doesn't do it with a negative power. So they've thrown us off here. Okay, so therefore we have to do this the long way. So remember, if they give you two values, a set of coordinates, they're giving you an x value and a y value. So we know that when y is 3, x is 0. So we can substitute those in as x and y into our equation. Okay, anything to the power of 0 is 1. So actually, what that's told us is that A is 3. Okay, if we do the same for the next one, so 0.48 is your y value for this one. We've just worked out A is 3. And that is when x is 2, so b to the minus 2. So if we think about negative powers, it's the same as the reciprocal of b squared. So I'm just going to rearrange by cross multiplying. So 3 divided by 0.48 is 6.25. Okay, and then you can square root your answer to get 2.5. So b is 2.5 and a was 3. Okay, so it tells you that A and B are positive constants, so we can ignore the negative root when we square root 6.25. Okay. Question 16, so more algebraic fractions. So remember, you just want to factorise as much as possible. Okay, so 8 and 50, I can take out 2 and an x in the numerator. That leaves me with 4x squared minus 25. And I've also got 2x. I'm just going to leave this one for the minute, but obviously we should be able to factorise it. Okay, so now I can see that my 2x and my 2x cancel out. So you're then going to factorise the top and the bottom. So the top, you've got a square number minus a square number. So therefore it's a difference of 2 squares. So it's 2x plus 5, 2x minus 5. And for the bottom, okay, if you factorise the bottom's quite hard to factorise, but remember, if you do the top's easy to factorise because it's different as 2 squares, it will help you out. So the reason I've done that so quickly is you know it's got to be 3x and 2x because there has to be a 2x in there. And you know the 5 has got to be with the 2x, so therefore the other bracket's got to be 7, and then you can just fill about with your signs. So we've got 14x here, when you multiply out 15x here. So to get minus x, we want this to be the negative and this to be the positive, which means your 2x minus 5, my pen will let me, is going to cancel out. So we're just left with 2x plus 5 over 3x plus 7. Okay, so some tricky factorising there, but do the easier one first and use it to help you with the harder one. Okay, now question 17 is nice because it tells you what to do. It's giving you the method. Okay, so by multiplying both sides of the equation by x to the half. So I'm going to multiply everything by x to the half. Remember, when you're multiplying, you add the powers together. So if I'm doing the first term, 2x to the 3 over 2 multiplied by x to the half, I'm going to add those powers together. So 3 over 2 add 1 over 2 gives me 4 over 2, which is just 2. So that becomes 2x squared. For my second one, I've got a power of a half, add a power of a half, because it's going to be a power of 1. So it's just going to be minus 3x to the power of 1. And then for my last term, I've got x and minus half, and then I'm adding a half. So I've actually got 7x to the power of 0. Okay, and anything to the power of 0 is just 1, so actually that will just be 7. So I'm solving 2x squared minus 3x, going to move the 7 to the other side, is 0. So that's obviously a lot nicer to solve. Okay, it says give your answer to recent figures. That's a clue that it doesn't factorise. So you've either got to use the formula if you haven't got a fancy calculator, or you can just put it into polynomial solver. So we've got 2 minus 3 minus 7 for A, B, and C. Okay, so then we've got 2.77. And minus 1.27. Okay, so actually it does become quite an easy equation to solve once you've done their little hint. Okay, how many odd numbers greater than 30,000 can be formed from these digits with no repetition of any digit? So 30,000. So if we're using all these digits, because we want a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you have to use all the digits. Okay, it can't start with a 2. Can start with a 4, 6, 7, or an 8. Okay, so to get my first digit, I've got 4 ways of picking the first number. Okay, 2's now back in it. So I've taken one of the numbers, we don't know which one. Okay, so I've now got 4 ways of getting the next digit. I've then got 3 ways of getting the third digit. And then I've got 2 ways. And then I've got 1 way. Okay, so we're doing 4 times 4 times 3 times 2 times 1, 96 ways. Question 19 is on the factor theorem. So remember, when you're using the factor theorem to show that a bracket is a factor, we're thinking about the root. So if the factor is 3x plus 1, okay, that would happen when x is minus a third. So if we sub minus a third in, okay, we should be expecting an answer of 0. So on your calculator, you can do this on a regular calculator. It doesn't have to be a graphic calculator. Okay, because I'm lazy and I don't like to substitute in. You can do this to substitute in if you've got quite a complicated expression. So you just type the function in. Okay, and then you can overwrite this. So I want minus 1/3. It does give me an answer of 0, so I've done it right. You do then need to summarize, so you can't just leave it at that. You need to say, therefore, 3x plus 1 is a factor. So it's like a conclusion. So you won't get the marks about writing the conclusion. You need to show it equals 0 and summarize. Okay, these questions are always very similar. So usually after you've shown that something's a factor, you then need to factorize it fully. You're going to do that using long division. So divide that original expression okay. So we're looking at the first term. So we're looking at just 3x. So how many times does 3x go into 3x cubed? Or in other words, what do I multiply 3x by to get 3x cubed? So obviously I've got a 3, I've got one of the x's, so I've just got to multiply it by another x squared. I'm then going to multiply these expressions. So 3x plus 1 by the x squared, which gives me 3x cubed plus x squared. So to find the remainder, I'm going to subtract. So minus 2x squared minus x squared gives me minus 3x squared. Okay, and obviously the 3x cubed and 3x cubed goes away. So I'm going to bring down my next term, which is minus 7x. Then I'm going to do the whole process again. So how many times does 3x go into minus 3x squared? So I've got the 3, I need to multiply it by a minus and another x. Then I'm going to multiply minus x by 3x plus 1. Give me minus 3x squared minus x. I'm then going to subtract to find the remainder. So minus 7x minus minus x gives me minus 6x. And bring down the last term. And then do the same thing again. So 3x into minus 6x, I need to multiply that by minus 2. And then 3x times minus 2 is minus 6x, and 1 times minus 2 is minus 2. Remember, you should always be getting a remainder of 0, because remember, it was a factor. So we now know that fx is 3x plus 1 multiplied by x squared minus x minus 2. Okay, but you can usually factorize that part as well. So you want to keep going. Okay, so then that gives you x minus 2 and x plus 1. Okay, so make sure you fully factorise by taking your answer to the division and factorising that as well. Okay, we've got a 3D trigonometry question. So we've got a pyramid. We've got horizontal rectangular base, A, B, C, D. V is directly in the centre. The sloping sides, so these ones are 10 centimetres. AB is 8 centimetres. BC is 6 centimetres. And M is the middle. So I'm going to put the 6 centimetres here, actually. And this bit in here is 3 centimetres. Okay, we're trying to find the size of angle VMD. So VMD, they've drawn that triangle in for you. So we're trying to find this angle here. So in that triangle, we want to find anything that we can find. So we obviously know that VD is one of the sloping edges. So we know that's 10 centimetres as well. So we've got to find MD and MV. Okay, so I'm going to start by drawing the base. Normally the base is integrated somewhere. I'm going to draw it in 2D as if I was looking directly down like a bird's eye view. So this is A, D, C, and B. M is the middle, remember? So we're trying to find this length here. Okay, we know that that's 8 centimetres. We know that's 3 centimetres. We know it's a rectangle, so I've definitely got a right angle at C. So therefore, you've just got Pythagoras. So to find DM, it's just the hypotenuse. We're doing 3 squared and 8 squared. So DM is the square root of 73. Okay, so that's one of the sides. The next one we want to think about is V to M. So I'm just going to draw out the triangle VBC. So imagine again you're looking at it in a 2D, you're looking straight on it. So you've got M in the middle here. Okay, and VM goes right down the middle. So we know the sloping sides are 10. We know this is an isosceles triangle because all the sloping sides are 10. Okay, so again, we've got a right angle triangle because you're just splitting an isosceles triangle in half. So to find VM, just doing Pythagoras again. Okay, but this time you haven't got the hypotenuse. We're doing 10 squared, take away 3 squared. Which is 91. So this is root 91. Okay, so you've now got all the sides in your triangle. So we know that DM was root 73. So this one here is root 73. This one here is root 91. The other side is obviously 10. Okay, so if we draw that triangle out flat as well, we had 10, root 91, and root 73. Just double checking those. And then this is the angle we're trying to find. So we can now use the cosine rule to work that out. So the cosine rule is given to you in this format. Okay, so that's A, that's little a. Doesn't really matter which one's B and C. Okay, but you can see we're doing 10 squared, 91, 73, Okay, so you can rearrange this. So we're just going to type that in, try that again. Okay, so we've got an expression for cos A is 0.392. And then inverse cos gives you 66.9. Okay, the other thing you can do, save yourself a little bit of rearranging. If you go into equation solver, okay, you can literally just type in the cosine rule as it was on that very first line. Okay, so if you type it in exactly as it is and press solve. Okay, you just need to be careful with these limits. Now we know it's going to be an acute or an obtuse angle. So put 0 to 180, it should work better. So there you go, solve 66.9. So I know I've rearranged it correctly. Okay, but just be careful, we have to have those limits. Don't normally use limits on solver, but obviously we do want a constraint on the angle. Okay, question 21. Show that this is divisible by 9 for all integers values of n. So just a bit of multiplying out brackets. So you can multiply out 3 brackets as you would at GCSE. So just expand, expand, expand. Okay, as we know about binomial expansion, I think it's easier to use binomial expansion. Okay, so if we're doing a cubed, we know the coefficients going to be 1, 3, 3, and 1. That's going to be 2n to the power of 3, and then 3 lots of 2n to the power of 2, multiplied by 3, 3 lots of just 2n to the power of 1. The 3's are going up in powers, and then 3 cubed, and then plus n cubed on the end. We've got 8n cubed. 3 times 3 is 9, times 4 is 36n squared. 9 times 2. Don't want to make any silly mistakes. So we've got 3 times 2 times 3 squared, which is 9. It's 54. Three cubed is 27. And then another n cubed. So group that together. So we've got 9n cubed, 36n squared, 54n, and 27. So if we're trying to show this divisible by 9, we should be able to factorise out 9, which we can. Okay, and again, you need to conclude and put like a little summary. So therefore, divisible by 9, because you've got that factor of 9 at the front. Okay. And that is the end of the question. It's quite a nice question for a last question, to be fair, on a paper. Okay, so I hope you had fun.